Hi. So today we will be discussing about one of the important concepts in probability about dependent and independent events. So at the end of this video, you will be able to understand clearly about what is dependent event and what is an independent event. Hi, welcome to this channel. I am Virendra here to help you with your studies. If you find this video interesting, do click on the subscribe button and the bell icon. You will be immediately notified whenever I upload a new video. Okay, today we shall learn about mathematics. And mathematics is an awesome subject. If you have found it very boring and very complicated then you are at the right place. I am going to navigate you through mathematics subject in a very simple manner. Okay, let's start. So far we have learned a trial, any experiment. For example, flipping of a coin. The trial will give rise to some outcomes. For example, in this case, if I flip a coin, I may get a head or a tail. So these are two different outcomes. The sample space is the set of all the outcomes. So here are two outcomes and the set of two outcomes is our sample space. The event is any of the subset from this sample space. Either a head or a tail becomes our event. So this is what we have learned so far. Now I am taking this little bit further. Is that let us think that I have flipped a coin and I have got a head. Then I am going to flip it again. Now what is the probability that I am going to get a head? The probability will be again half, because I can get a head or a tail. I do not know, right? So there are still two possible outcomes, and out of that I may get one head or one tail. So it's still the probability is half. Assume that I got a head. And I am going to flip it again. So what is the probability that to get a head again? Still the probability will become half, because I do not know again that whether after getting two heads, whether I am going to get a head or a tail for sure, right? So therefore, again the uncertainty of getting a head remains the same. So the probability again becomes half. Assume that again we get head. What is the probability that if I toss the coin again, I will get a head again? By looking at the previous three incidents, can I say that for sure the fourth time when I flip the coin, I will get a head? No. I may get head or I may get a tail. So the probability still remains the half. In this case, where the happening of the event does not depend upon other events, in that case, it is called the independent event. It is independent of happening from the other events. Whether other events are happening or not, the probability of happening of this event is completely independent and it depends upon its own probability. Now, I am just taking another example. For example, in a race in the school. Let's say that in the class you have 50 students and you have to choose who will become the first 1, 2 and 3. So you have to select top 3 from the 50 students. Now, if you conduct a race of all the 50 students, the race becomes too crowded and it becomes really difficult for the students to run. What you essentially do is split these 50 students into 5 groups of 10 students each. And then conduct one round and select two of from each group. So essentially you will land up with 10 top runners from the whole 50 students, and then you conduct the final round, which will essentially give you your top 3 that you need. So this is the final round. And this is your first round, right? So the probability of coming in top 3 is dependent on the probability that you will be coming in one of these top 2 runners or one of the top 10, right? So coming in the top 3 is not an independent event, right? It is dependent on coming in the top 2 from each group, right? First thing is the dependency is there that you should come in the top 2 in the first round itself, or top 10 in the whole bunch, and then you will be able to qualify for the final round. Let's say event B is coming among the top 3 and event A is coming among top 2. Event A is coming among the top 2 from each group. Now these two cannot be independent events, right? The event B is always dependent on event A. So this type of events are called dependent events. Dependent events. Let me give you some more examples. Let us say that you have a coin and you have a dice. So if I say that getting a head or getting a 3, are they independent or dependent events? Look, getting a 3 from a dice doesn't have any kind of relationship with the getting a head if I flip the coin, right? So they are completely independent. So getting a 3 and getting a head are completely independent events, right? I'm giving you another example. Let's say you have a bag and you have 3 balls red color and 3 balls of black color, and if randomly you are going to pick a ball, then what will be the probability that it will become a red ball? Now, there are 3 red balls. Think about the probability formula. Number of favorable outcomes divided by total number of outcomes. This we have discussed in our previous video. I will give you the link for the previous video on the description. Please go and visit the video for how did we arrive at the formula for the probability. Okay. Now, what will be the probability that it will become a red ball? There are number of favorable outcomes will be 3, because there are 3 red balls. Any of these 3 red balls if I get, then that will become my favorable outcome. Because what I am going to consider is what is the probability that I will pick a red ball, right? So the numerator becomes 3, and what is the total number of outcomes? That could be 6. I could pick any of these 6 balls. So if that is the case, I have total number of 6 outcomes. So 3 by 6 will be my probability, right? Or simply it is 1 by 2, right? So what will be the probability of getting a black ball? It is also going to be 3 by 6. So again, the same formula applies, and I can say that 1 by 2 will be the probability for getting a black ball. Now, once I pick the ball, let us think that it turned out to be a red ball. So in the bag, I have only 5 balls. Now, if I am going to pick another ball out of the bag, what is the probability that it will become again red ball? This time we have to think. Now, what is the number of favorable outcomes now? Now only there are 2 red balls. So therefore, in the numerator it will become 2. And what is the total number of outcomes? This time it is 5. So this is 2 by 5. It is no more 3 by 6. So be careful about, if once you have taken out the ball and you are not replacing it and you are taking out the second ball, then the probability changes. So taking out the second ball in this case became a dependent event. The probability of picking the second ball is completely dependent on the picking of the first ball. So the second event is the dependent on the first event. Now I am turning these things. Now think about the scenario. After picking the red ball, I am going to replace it in the bag again. So that means again I replenish the red ball. So again the number of the red balls inside the bag became 3 and the total number of balls inside the bag became 6. So if I am going to pick another ball, or if I am going to pick the ball for the second time, still my number of favorable outcomes becomes 3, because now I have 3 red balls again, and the total number of outcomes will become 6 because I have all the balls intact inside the bag. So therefore my probability will still become 3 by 6, and that is equal to 1 by 2. Remember, in the previous instance it became 2 by 5, right? In the previous instance it became 2 by 5 and that became our dependent event, but in this case it still remains 3 by 6 and these 2 events became independent events. Hope this clarifies the difference between the dependent events and independent events. Hopefully you have watched this video carefully. If you have not understood, please revisit this video, and if you have still not understood, please put your comments on the comment section. I will try to clarify your doubts. Thank you for watching this video.